Unit 12, Day 3, Graphing Linear Inequalities Applications. So we get to do some word problems, okay, which is where I personally think things get a little fun. All right, so first we have a little bit of review. Okay, so we want to get y by itself here. So again, on both of these, I'm going to box in the y term. In this case, it's a minus 2 over here. All right, so but over here I need to subtract 3x because I have a positive 3x. So I get 4y is less than or equal to negative 3x plus 12. Because these two don't play nicely together, positive 12, negative 3. Okay. Now, I'm going to have to divide by 4 right here. So the question becomes, am I going to flip the sign? That answer will be no. Okay, because this is a positive number. I'm dividing by a positive number. So no flipping goes on. So we'll get y is less than or equal to negative 3/4 x plus 3. Okay, now I'll just skip down here. Let's see. All right, so I need to graph that. Take the point 3, the y-intercept is 3. Slope's negative 3/4, so down 3, up. Those are actually the only 2 points I can get. All right, dashed or solid? Less than or equal to. Less than or equal to. The bar underneath there tells you it's going to be solid. All right, so this is going to be a pretty awful line, so pardon me. There we go. All right, and it's less than, so it's below. Solid and it's below. All right, so this point right here, they ask us, is 0, 3 a solution? So 0, 3. Fortunately for us, we just put that point down there, so we know that that is actually on that line. Even though my line's not perfect, we know that point's there. Okay, so is it in the shaded area? No, not in the shaded area. That would be down here. Is it on a solid line? Yes. So it is a solution right there. Okay, we know it's a solution because it's on that solid line right there. Okay, let's look at this other one. Well, I've already boxed in my y term, so I need to subtract 3x. Okay. All right, so these two cancel out. We get negative 2y greater than negative 3x plus 10. Okay, now I have two problems here. The really big one that's staring at me is that my y is on this side. I don't like my y being over there. I want it to be over on the left side. Okay, so first thing I'm going to do is I'm going to take this whole thing right here and I'm going to reflect it. Okay, so I'm going to flip it over so that I'm going to have negative 2y is less than negative 3x plus 10. Okay. All right, so forget this thing over here. I'm dealing with this. I want the y over here, so I need to get y by itself. Well, in this case, I need to divide by negative 2. Well, there's a rule we already said. When you multiply or divide by a negative, you flip the sign. So this is actually going to be flipped to a greater than sign. So y is greater than, let's see, it's a positive 3 over 2x minus 5. So there's actually our inequality. I guess I could have written it over here. There's my inequality that I can graph. All right, so when I go to graph this, I'll start at minus 5 and then up 3 over 2. Up 3 over 2. And I can't go any farther. It's going to be somewhere over there. All right, now this is going to be a dashed line, and I'm going to shade above, okay, because it's greater than sign right there. So dashed and above. So above is actually a lot of this graph. Okay. Now to determine if what we have is a solution, negative 4, 3. Yeah, that point is definitely in the shaded area, so it is a solution. It is a solution. Okay. All right, number 3. Adam is ordering helium balloons for his sister's birthday. Now, first thing, I guess I should point this out. We did problems like this yesterday. And a little bit the day before, I believe. We touched on it just a little bit. Okay, this is mostly what we're going to be doing now. Okay, so we really want to get used to this. All right, so try to remember what we did yesterday on our notes, or get those notes out for that matter. Okay, Adam's ordering helium balloons for his sister's birthday. He has a maximum of $15 to spend. Now, the other day I pointed this out, maximum $15. That means you cannot be, so if it's the highest you can go, you can't go above that, right? So if my maximum is here, I can't be up here. Okay, I have to stay below it. So that means I'm going to be less than or equal to 15. I have to stay below it. Okay, now next, decorative balloons cost $3 each. Solid colored balloons cost 50 cents each. Okay, so decorative balloons, $3 each. Solid colored, 50 cents each. So that actually tells us our two variables. I could use x and y. I'll go ahead and do that. I'll do x and y. Okay, so x equals, we'll do decorative balloons. And y is solid balloons. Okay. So writing the inequality, and often this is the hardest part. But once you get the hang of how we do this, there's really nothing to it. We said it's going to be less than or equal to 15 from the maximum up there. Let's see, decorative, the x costs $3 each. So 3x plus 50 cents times y. Cents times y. And there's our inequality. All right, so I know for a fact it was actually going to end up being below, okay, because we have a maximum here, so we need to be below. All right, so we actually went ahead and labeled that. We said x was decorative balloons. Decorative balloons. And we have the solid balloons. Okay, so if you only had solid balloons, or decorative balloons, sorry, they're $3 a piece, $3 a piece, with $15 to spend. So if you were just going for that, you could get exactly 5 decorative balloons, and that'd be it, 5 balloons. Okay, well maybe those are nicer, that's why they're more expensive. Okay, or we could go for, instead of for quality, we can go for quantity. We could say, let's get the solid color balloons, they're cheaper, 50 cents each. Well, so half $1, you get $15. So you actually can get 30 of them. So you can get a lot of those solid color balloons because they're cheap. All right, so that means whenever I go to connect these two lines, these 2 points, using my straight edge, all right, my cost has to be below that. So I'm going to shade below that. So I'm looking for 2 possible combinations. Well, these combinations can be anything that's in this area, right? So it could be that I get 5 decorative balloons and no solid colors. I could very well do that. Or I could go for a good mixture and say 2 decorative balloons and, what is that, like 10 or 11? 2 decorative balloons and something like 10 solid balloons. Okay, I could also do something like that. Now there's lots of options I can have there. Okay, but now this last one, what is the maximum number of solid color balloons they could purchase? Now we said they were 50 cents a piece, so the most we could get is actually 30. Most we could get is 30 solid color balloons. Okay, number 4, Ada has at most 280 beads to make jewelry. A necklace requires 40 beads. I feel that's going to be important. A necklace requires 40 beads, and a bracelet requires 14 beads. Okay, and then this at most 280. That's kind of important too. Okay, now the thing is, at most, again, if we can have at most this much, that means we need to have that much or below. So we actually need to be less than or equal to 280. We're capping it off. We can't go any more than that. Okay, now we have a necklace and bracelets are two variables, two things we don't know. We don't know how many of each. So let's just go ahead and say X is necklaces and Y is bracelets. Okay, so again with our inequality, we're going to have 40x plus 14y is less than or equal to 280. Okay, now I'm going to wave my hands a little bit here, but if I wanted to get this by itself, if I wanted to get y by itself, I would have y is less than or equal to, let's see. So I'd subtract 40 over here, divide by 14. So I'd have negative 20 over 7x. Okay, and that'd be plus 20. Okay, so my graph would start at 20, and it would go down 20 over 7, which coincidentally, if I just divided by 40 right here on both sides, I would get 7. 14, I would get 7 for the, or 20 for the necklaces, so for the bracelets. So this actually will work out just the same way like the other ones. I just went ahead and rearranged. I could get y by itself and it would work out just exactly the same. Okay, so let me go ahead and label this graph down here. I've got X is necklaces, bracelets. All right, so this is going to be less than or equal to. So now here's the thing. My graph's a little off. So I know it's this area down here, but I want to be kind of careful when I pick these potential points. Oh, actually, here we go. Is 1.54 a reasonable solution for the inequality? Well, 1.5 would be somewhere in here, and 4. It would definitely be the solution. Okay, definitely be a solution. The question is, though, is it a reasonable solution? Does it make sense? Well, 1.5, 4. So 1.5 necklaces. Can you make 1.5 or sell 1.5 necklaces? No. Okay, it is not a reasonable solution. Okay, so we'll say it that way. I'll say no. 1.5 necklaces is not reasonable. Okay. Okay, now the last question of this is what's the maximum number of bracelets that Ada could make? Bracelets. Okay, so according to our graph, the highest number in the y-axis, the bracelets we could get is 20. So 20 bracelets. Okay. All right, number 5. Beverly's serving hamburgers and hot dogs at her cookout. Hamburger meat costs $3 per pound and hot dogs cost $2 per pound. She wants to spend no more than $30. Okay, so no more than. That means she does not want to be more than, so she needs to be less than $30. Let's see, we've got hamburger meat costs $3 per pound. Hot dogs cost $2 per pound. Now, if you notice, I mark these up quite a bit because if you think about the EOC, at the end of the year, you are going to be able to mark and write on your screen as much as you want. So feel free to use highlighters. Feel free to use different colored pens or pencils to mark these things up to make sure you know the important information, the pertinent information. All right, so the two things we don't know based on what we've just circled here are hamburger and hot dogs. So X for hamburger, X is hamburger, hamburger meat, and Y is hot dogs. All right, so our inequality is going to be 3x plus 2y is less than or equal to 30. Okay. Less than or equal to 30 because not more than $30. And with $3 per pound for the hamburger, $2 per pound for the hot dogs. And so there we are. Okay, so if I got just hamburger's $3 a pound. So if I just got that, I can actually only get 10 pounds. $3 a pound, 10 pounds, $30, okay? So I could only get 10. However, if I only got hot dogs, I could get 15. I could actually get a little bit more because those are cheaper. Okay, so now I'm going to have to connect those dots. All right. Okay. With your straight edge, you can get it perfect, just about. All right, so if I picked, oh, wait a second, it is less than, so it's going to be shaded underneath here. All right, so give two possible combinations. So I'm going to be kind of careful. I'm not going to pick any that are close to the line because I want to make sure they're actually in the shaded area. But let's say, I don't know, you could pick a bunch of these, but 3, 4. That would be 3. Oh dear, I didn't label my axes down here. We had hamburger down here. Hamburger and hot dog. So 3, 4 would be 3 pounds of hamburger, 4 pounds of hot dog. Okay, so 3 pounds hamburger and 4 pounds hot dog. Let's pick another point. How about 5, 7? So that will be 5 pounds hamburger and 7 pounds hot dog. Okay, and then this last question, what is the maximum number of pounds of hamburger she could purchase? Well, again, hamburger is the X down here. Okay, it's all down here. So the maximum we have on our graph is 10. So 10 pounds of hamburger. And there we have it. Okay. All right, so next we have Lola. Okay, Lola can spend $20 up to, there's some words we need to know, up to $20 on snacks for a study session. Muffins cost $4 each, and bagels cost $2 each. All right, so the two things we don't know in this are pretty obviously the muffins and the bagels. So X for muffins, Y for bagels. Okay. All right. Now, in our inequality, we know that muffins are 4 each, so 4x, plus bagels are 2 each, and up to $20. That's our limitation. Okay, so when there's a limitation, that tells you that it's going to be this side of the inequality. Okay, so up to 20. So she could spend 19. Right? She could spend $19.50. She could spend $18. As long as she is not over $20, she has to be less than or equal to. Okay, so less than or equal to. So that means we're going to be shading below on this graph. Now, if she only got muffins, how many could she get? Oh, I need to label this graph again. Okay. So we need to label this, so X is muffins and bagels. All right, so if she only got muffins, they're $4 a piece, so we could actually get 5 of those. But if she only got bagels, 2 a piece, they're going to be, we could get up to 10 there. All right, so we'll connect those dots. Okay. and we're shading below. So it's all below here. Now, we need to be really careful with this because my line is not very straight. Okay, so I'm going to try to pick some things I know we're going to land in here, like 2, 1. All right, so I could have 2 muffins and 1 bagel. Okay, I could also do, I don't know, say like 1 and 4. 1 muffin and 4 bagels. Now, something I could do, I have not done this yet, but I could do this actually. Let's just think this through. Okay, on the side, let's think this through. 2 muffins. Well, that means it's going to cost her $8 for muffins and $2 for the bagels. So that's less than $20, right? Okay, so she's going to spend a total of $10. If she did 1 muffin, that would be $4. And 4 bagels, well, they're $2 a piece, so that'd be $8. So that's $12. So actually, both of those check out. Those numbers make sense. So probably could have been doing that this whole time. Our last, well, actually I have 2 more. Could 2, 2.5 be a possible combination? Okay, so let's do this. Make sure I'm in a good color. So 2, 2.5. Make sure that's nice and big. That's the one I'm talking about with E. Could it be a possible combination? Well, it's in the shaded area, so could be a solution. That's one thing to notice. It's in the shaded area. That is a big thing we need to point out. But let's also think about this. 2. Can you have 2 muffins? 2 muffins. Makes sense, right? You're buying these, so you're buying them in whole numbers. Could you buy 2.5 bagels? Yeah, you know, more I think about this, you could justify this. Okay, if you could convince me that, yeah, okay, I could only buy half the bagel and I'd be okay because they actually come in halves. That'd be one way to think about that. But I'm going to say no because generally you don't buy half a bagel. All right, you don't generally do that. Generally, we buy those in whole parts. Okay. All right. Now we can't answer this last one. What's the maximum number of muffins that Lola can purchase? Well, looking at our graph, the highest we can get over here is 5. So 5 muffins. 5 muffins. Okay. All right, number 7. Jacqueline's making a punch for her office party using cranberry juice and sparkling cider. She can make at most 20 cups of punch. Define the variables, write a linear inequality to represent the situation. Okay, so what all are the things we don't know here? Well, we don't know how much, since it says she's going to be combining these two together. So it's cranberry juice and sparkling cider. So I'm just going to say X is my cranberry juice, Y is my sparkling cider. And she can make, here's our limitation, at most 20 cups of punch. That means less than or equal to. Oh, I guess I need to define those variables. It actually says that. X is cranberry juice, and Y is sparkling cider. All right, so if I put those two together, X plus Y, you add the cranberry juice and the sparkling cider, you put those two together, we ought to come up with that whole juice, right? The whole punch. Well, her punch is less than or equal to 20. So less than or equal to 20 cups. So that is actually our inequality right there. Cranberry juice plus the sparkling cider has to be less than or equal to 20. Okay, let's look at this last one. Okay, the points 0, -1, and 8, 5 lie on the boundary line, but neither point's a solution. The point 1, 1 is not a solution. Write and graph an inequality that has the solution described. All right, so we've got 3 points here. So 0, -1, and 8, 5. Now these two lie on the boundary line. So our boundary line is our dashed or solid line. Okay, they lie on that line, but neither point is a solution. How could that be? It's really more of a puzzle, honestly, this problem is. Neither one's a solution. Well, that must mean that it's dashed. Must mean it's dashed. It's dashed. Okay. Now the point 1, 1, let me put that point right there, is not a solution. So where are the solutions? They're definitely not over here. They're not above the line, so they must be below. They must be below the line. All right, so there's sort of what that's going to look like. Okay, so there's the graph. We actually were able to do the graph just based on these clues alone. It's not a solution. It's neither point's a solution. So knowing where the solutions aren't, we can actually determine where this is, what this graph's going to look like. But to write the inequality, we want to have y is less than, because we shaded below, not equal to because it's dashed. And we need the slope and the y-intercept. Well, the y-intercept is right there. It's -1. So we're going to have -1. And we need to figure out the slope. So let's see. I got these 2 good points on the line. I'm going to use those 2. So the rise is 1, 2, 3, 4, 5, 6. And the run is over 8. So it's going rise over run. Which is 6 over 8, or 3/4. So 3/4 x. Y is less than, because it's below, 3/4 x minus 1. And that is our inequality.